the tremendous role you're playing in that seed level investment in research that a lot of the government agencies won't fund because they're late stage. They want data, et cetera, et cetera, et cetera, et cetera. The work you're doing is just unbelievable. And thank you for not only the work you do, but for being here today and bringing Dr. Wahl and Bianca to the show. And on that note, Dr. Wahl, we're going to turn it back to you.
Right. So where was I?
We were talking, before when we were on our break, we were talking everything from plasticity to chameleon to everything these cancer cells are doing to try to not get caught.
Right. And that's their job, right? I mean, once a cancer cell forms, its objective is to live. It doesn't know it could kill the host. It just has to survive. And as the cancer cell grows, it's constantly challenged with changing environments. And so it has to become adaptable. And the way it becomes adaptable is by reprogramming itself.
By the way, adaptability is basic biological evolution, right?
It's Darwin.
Right.
So this is Darwinian evolution going on inside your body, 24 hours a day, 7 days a week, et cetera, with no vacations and no furloughs. And so the cancer becomes very adaptable. It becomes so adaptable, then often so our research has shown, research funded by Komen and then later funded by the National Institutes of Health, is that the cells can reprogram into this embryonic-like state that was anticipated in the mid-1800s, okay? It isn't like your embryonic stem cell. It's like the most primitive form of cell that generates the breast in the first place, okay? That's what we found out. But we found out something else. One of the big problems in cancer, as Bianca mentioned, is early diagnosis. And we'll get into wise diagnosis later. It's not just sufficient to do it early. You need to do it wisely. But the second thing is that metastasis, the ability of these cells to move from their site of origin in the mammary gland, the breast, to distant sites along the bones, the brain, is what kills people. And there are many ways that happens. We discovered a new way that we were never thinking about. That's why we do science. We come in to see the unexpected, right? To look at that vista, to the horizon, to say, oh my goodness, this sunset is beautiful, right? Well, in this case, it's a new way that breast cancer cells can metastasize. And that, again, has to do with acquired plasticity. So the adult breast cell reprograms itself into a cell that the developmental biologists call neural crest. This is a type of cell that's formed very early on in development and is designed to move from like the spinal cord area to distant parts in the body where these cells generate different organs. And that's what these breast cancer cells have learned to do. Now, why is this important? Your podcast is LAST, Leadership, Advocacy, Science, Therapy. Okay, this is what gets from the science to the therapy part, because now we have a new kind of cell that's formed in the adult, this neural crest cell. It isn't supposed to be there. It has novel targets in it. And we are characterizing these cells now in great detail to find what those targets are and to attack them. Now, it turns out that cancer is as many diseases as the people who have it, okay? And that's why it's so hard. We should never think of it as one disease. Right. We should think of it as a moving target in many diseases. Here we have a case where we've identified one of the means of movement, and it turns out that these cells, these neural crest-like cells formed from the breast, are expressing proteins for which we already have drugs designed for another kind of cancer. This is the power of modern molecular biology applied to cancer research. Because even though the cancers are different in different people, they share underlying principles, and as we get more sophisticated and identify those principles, we can take drugs that are already known to be safe, used for one cancer, and use it on another. One of the examples of this is the use of Gleevec for chronic myelogenous leukemia to also treat people with gastrointestinal stromal tumor. Well, it turns out that one of the drugs that was designed for that is actually a drug we can use for these metastatic cells, and we're trying that right now.
That's great. It is amazing.
I'm excited. Don't know about you guys.
I am. Well, and talking about metastatic breast cancer, we know we're still losing 41,000 women a year to metastatic breast cancer. Is the majority of the reasons those women are dying. So it is so exciting to see that you are
with
learning.
with your help and Bianca's inspiration.
Yes. Like this community is really being able to learn more about it and know how and why those cells are moving to create that metastasis.
Again, let me make sure that everybody understands this isn't the only way.
Right.
There are many ways. It's like Charles said. I mean, the purpose here is for these cells to become adaptable.
Right.
And once they are, there are many ways that they can use to survive. And this is one way.
If you want to think about that in the human terms, a lot of times a patient will receive a certain type of drug therapy, and it might be very successful, but especially those with metastasis. But they'll find that after a time, their tumor or their cancer becomes resistant to it because of that adaptability. So then they have to look for a entirely different set of drugs or therapies to it.
But there's something really. It's the more I hear Bianca and I hear you discuss this, and Dr. Wahl, it's. Where the whole world's talking about artificial intelligence these days, which of course there's nothing artificial about it because human beings are powering it, and then machine learning. Dr. Wahl, I'm about to say something which may sound dumb, but these cancer cells are machine learning at a level we can't even fathom. That's what I'm hearing from you.
Well, Charles, it's interesting you said that because yesterday's lab meeting was spent discussing a paper that we're just writing now on machine learning in cancer, where we have to think. So in the past, we've analyzed cancers as a big mass. We've taken them out and smashed them up and analyzed all the information that they have together. But what I've told you about is the importance of understanding the individual cells within the cancer. What's each individual doing? How are they communicating with each other? How are they communicating with the host? And so now what we've done is use the most sophisticated methods that are currently available to analyze each individual cell, not only in the developing mammary gland, because I told you we have to understand cancer as a problem of development gone awry. Right? And now we're understanding how these genes are kind of working together to go from one step in development to another, and now applying that to cancer in real time.
Yeah.
So, machine learning.
It's unbelievable.
Yeah, we can't apply artificial intelligence. We have to apply real intelligence.
Yes.
Because somehow these cells have learned at a very, very fast pace how to adapt and evade this cat and mouse game.
And this is where the use of immune therapy comes in, because cancer is the most adaptive of diseases, and our immune system is the most adaptive of mechanisms to thwart it. Now, cancers arise and they develop ways of becoming resistant to the immune system, and there are many ways by which that happens, and that's why many people are not responding to immune therapy. It took 30 years to get immune therapy into the clinic. A lot of courageous researchers were doing that, and now we're learning at faster paces how to harness the immune system in more intelligent ways to enable more people to respond to those. But that's not going to be the only therapy, right? It's like Bianca said, we're going to need to adapt as the cancer adapts and need to use multiple strategies.
The other thing, Dr. Wahl, I'm sitting here thinking, and Bianca, moved by your story of chemo and coming into the lab and seeing this.
Thank you.
I have a hunch there's a lot we can learn from other industries. For example, if you think about the war in Vietnam, and we thought the military had an idea how we can win, just drop bombs. It doesn't work. That's why the special forces are so effective, because they think differently. The question is, it's almost like this special forces approach, whether it's personalized, all these different strategies is how we're going to ultimately overcome this enemy, so to speak. So give me a thought for the thought process. Do you try to think like a cancer cell? Why are you doing this? So see it from their perspective to help get an edge. How do you think through this challenge when you're in your lab?
I speak to people who are a lot smarter than I am, for one. Those are my graduate students and postdocs and professors at other places. And you're bringing up a really important point. The most important advances in areas usually come from the intersection of fields, talking with people in areas that usually don't talk with one another. So, for example, we're working, with people who do microfluidics in order to think about how cells move and how they get away from the place where they were and what the forces are that are interacting there. We have to deal with people who are very sophisticated mathematicians to work on these machine learning and artificial intelligence programs. And we're blessed in San Diego to actually have UCSD across the street from us and a number of biotechnology companies and big pharmas where we actually do talk with one another. I've heard it said in the public, scientists keep everything to themselves. Oh, you've already got cures to cancer. You just don't want the companies to go out of business. That could not be farther from the truth. We talk with each other all the time because our objective, remember, the title of this podcast is LAST, and the first word is leadership. And so even though I came from a small lab, even though I have a small lab, I took this leadership position at the American Association for Cancer Research, which is the largest and oldest cancer research organization in the world. And one of my objectives there was to increase communication among various sectors.
May I speak to that? As far as I know, Jeff is the only person who has an advocate as a regular resident lab member. So it's just been an incredible thing. And we'd like to see it emulated more. But I don't know if everybody is as generous as Jeff is in inviting everybody in, but hopefully they would be because
I keep encouraging it.
Yeah.
Well, there's no question, and we'll jump on that when we come back, maybe talking about the ethos of the research world and what that means to leadership. But you've been listening to The Last Battle with Dr. Geoff Wahl, Bianca Kennedy, and our co-host today, Lizzie Wittig from Komen San Diego. We'll be back in a few minutes.
Thank you. By listening, you help prove that content marketing works. You need to engage your customers. We provide the solution. Contact Wade at WSRadio.com or call 866-WS-RADIO.
Hi, this is Rob Barnett, VinVillage.com, where wine lovers connect. Be sure to tune in weekly to Vin Village Radio for exclusive, in-depth interviews with the who's who in wine and food.
I can't speak more highly about Progressive Medical Center and how they've helped me get my health back, get my energy back. And Dr. Agoli, when I first came to you guys, you found a thyroid problem, and I had no clue. But that's really common with a lot of your patients, right?
Underactive thyroid is the most misdiagnosed condition in the United States. According to the American Academy of Endocrinology, well over 25% of the population is not being diagnosed properly. It's because of the testing parameters. If you go to your traditional doctor, they could be missing a key component. If you have crushing fatigue, inappropriate weight gain, cold hands, cold feet, losing hair, lack of concentration, even headaches and migraines could be caused by underactive thyroid. At Progressive Medical, we get to the root cause of the problem because we are integrative, and integrative medicine is good medicine. We use a combination of medication, natural supplements, diet, nutrition, lifestyle modification, and that's what makes it so unique because we tailor it to your personal needs, and that's interesting because you are tailored.
Yes, and if you want to get your energy back, be the most vibrant version of yourself, you got to get to Progressive Medical Center. I'm so glad I went. Contact them today through progressivemedicalcenter.com.
The Last Battle is the show where we explore the latest and greatest on leadership, advocacy, science, and therapies in the battle against cancer. On The Last Battle, we'll be exploring with global innovators and leaders the many exciting developments driving optimism in the world of cancer. Great thanks for listening as we move forward with The Last Battle, a Cloudcast Media production.
Welcome back to what I'm sorry to say is the last segment of today's episode of The Last Battle. We've been having such a good time in exploring leadership, advocacy, science, and therapies with Dr. Geoff Wahl, Bianca Kennedy, and our co-host today, Lizzie Wittig from Komen San Diego. This last segment is brought to you by Love Surf Vacation Homes, a luxury vacation rental company and a division of American National Investments. This is Charles Parisi, and welcome back. And let's just kind of get right back at it and use our time well. What do you think, Lizzie?
I know this has been a great discussion, and we could continue for days, I think. I wanted to, something you just said before we went to break, Bianca, and how you would like to see more of this integration of patient advocates and everything. And,